In this new episode, I would like to introduce the Gen-tendency function. Gen-tendency is a very useful function to generate some value who follow a path you describe by a number between 0 and 1. For example, if I want, you can see the parameter here. If I want 64 value going from 0.121.0, kind of crescendo. Actually, it's only data. I can graph them. And you see, this is a tendency, not a line. That means it follows the direction from 0.1 to 1, but around the path. And what is really interesting is you can specify the variance. For example, with a very small variance like 0.01, it's almost a line. But with a big variance, it's almost random, but still follow the path. This allows you to design some vector who follow a path and a direction, and to give direction to your music. Let's see how we can use it in a small study. Here, first I load a template in a Vienna Ensemble Pro. This is my template. And now, let's say we describe a path, a master tendency. This is the values of this master tendency. I want something that goes up and down with few change in the middle. So this is my global direction for these small studies. So here I define the number of value I want to generate. Now we will use this tendency, this vector, this master tendency, these values. We will use it with Gen-tendency to generate a pitch vector. For now, I define the variance for this pitch vector to 0.7. So you see the parameter variance here, and I'm using global pitch variance. So I'm calling the function Gen-tendency with number of value 32, you remember? 32 values. And the master tendency vector. So I will get something who follow my vector. Here it is. This will be my pitches, my first vector. So I want to compose for a Pierrot ensemble. So I need 6 vectors. So let's do the other one. always follow the tendency. Now I will convert this vector, pitch vector 1, 2, 3, 4, 5, 6. I will convert them to pitch according to some register. So I will use the function vector to pitch. And for my violin, my first line will be for the violin. So for the flute, sorry. It's flute, clarinet, violin, cello, and piano. So for the flute, I will convert between G4 to C7. So this is my pitch vector 1. And I convert it to pitch and put it in the variable pitch. So maybe I can use a faster value for audition. Now I do the same for second vector, convert to pitch, but with a different register. For the clarinet, again for the violin, for the cello, for the right hand of the piano, and for the left hand of the piano. So now I have some vector, pitch vector. Naturally, it's possible also to plot the vector all together like that. You can say vector 1, 2, 3, 4, and 6. So we can have a look. So actually we have only point, but if we add join points, true. So here is the 6 vector for the pitches. Now the dynamics. For the dynamics, I set a variable global invariance, but a very smooth one, 0.01, because I don't want abrupt change of dynamic, but a smooth change of dynamic. Again, I use the same technique. I will put the value of dynamic in my variable tin vector 1. I'm using the function Gen-tendency. I will generate NB values, so 32 actually, follow the master tendency map, and apply this variance. So here is a dynamic vector, so I can evaluate this expression. And you see the number here. We can have a look as well. So you see this one is very smooth, because the variance is very small. So I generate for each my musical line. And now we will map to dynamics. So I do a variable dynamic map from pianissimo to forte. And with the function vector map, I will map my dynamic vector on this dmap value. So I will get my dynamic 1 list here. And as you can see, it follows globally the vector pianissimo, fortissimo, and go down to pianissimo. I do the same for the dynamic 2, 3, 4, 5, and 6. Now I do a list of lengths. So for this simple example, I use only one rhythmic line. So this rhythmic line will be for the sixth part. Let's have a look on it. Now we will assemble this material. I declare with setf a variable omn1, and with the function makeOmn, for the pitch parameter, I call pitch1. You remember pitch1 was generated by the pitch vector 1, and using vector to pitch was a conversion from pitch vector 1 to pitch. And that's the same for all other pitches. So this is pitch 1 for the pitch, the length value for length, the velocity list we generate for the first from the first vector, and I use span pitch in my makeOmn. It means the makeOmn will follow the number of pitches, not the number of length. So the master are the pitches. So when there are no more pitches, makeOmn stop to generate the material. So we can have a look to this generation. Making a snip. I do the same for each musical line according to the parameter we generate. Now I distribute to instruments, so I do a variable flute, and I pass omn1 to this variable, but I use also the Opusmodus function velocity to dynamic. So it will add crescendo and decrescendo between the velocity values, convert the velocity to dynamic, by the way. So if you look at omn1, this is omn1, and if you look at omn1 after the treatment, the process of velocity to dynamic, here is the result. You see? This is the dynamic. This is the effect of velocity to dynamic. So I give to clarinet omn2 with the same kind of process, omn3 for the violin, omn4 for the cello, omn5 for the right hand of the pianist, and omn6 for the left hand. Now just remain to design the score. So naturally I'm driving my Vienna Ensemble Pro plugin host, but you could use a template, General MIDI like that, template, chamber group, Pierrot Ensemble. And now, as you can see, I have a Pierrot Ensemble template ready to use. But for this example, I did the same. I use a Pierrot ensemble, but I changed a bit the parameter to be able to drive my Vienna Symphonic library. So this is the depth score. The depth score typically have what we call a header with a title, composer, copyright, and so on. Some information about the layout and the instrument distribution. I evaluate this. And now let's see what is the output of this. We can also output in the MIDI player, so we will see, we will get a better view of the global shape. See you soon for another episode of Zoom into Opusmodus. Bye.